the underlying crime rate is stationary in time if you're not including time in your model. So you're assuming over that time window that crime is stationary. Furthermore, you're assuming that rate extends into the future. So that would be one approach that's been proposed. And then alternatively, another approach in 2004 is prospective hotspot maps which do include time. And this is the idea is you weight events farther in the past less than you do more recent events. And what is this mathematically? Well, it's exactly the triggering kernel in a self-exciting point process, right? So, so the prospective hotspot maps was designed to deal with near-repeat victimization. Okay, so what do you do with that? Well, a few things to point out. So just like pin maps, prospective hotspot maps also have high variance because they decay in time pretty quickly as they're typically implemented. So you're really only using a few weeks or a few months of data to estimate the risk of crime. So even though they're better than pin maps, they have that high variance that you don't want. Stationary hotspot maps don't take into near repeat events, so that's not good either. And also, as they're typically implemented, you also have this variance issue because you're only using a few weeks or few months of data, which is common in police departments to do. So I think of self-exciting point processes as just, a nice way of kind of taking the benefits of both of those types of hotspot maps. So you get the background rate is where you get fixed environmental heterogeneity, and furthermore, you can use as much data as you have available to estimate that background rate. Why not go back 10 years to estimate that background rates? And then it also takes into account the near repeat event effects. It has the triggering kernel associated with it, so you can get emerging crime trends in the model. And I tried to talk a little bit more in depth about the EM algorithm because the EM algorithm is really what you need to do a fully automated prediction algorithm, meaning we can hand this off to the police department and not talk to them for 6 months, and it will run every day. And unlike Newton's method where it'll, just break all the time, this will actually give reasonable results every day without oversight. And also, you just use the data that police agencies already have in their RMS. Okay, so just a final word about hotspot maps and point processes. So this is, the lesson is, I think more data gives you better predictions. And there's this quote floating out there by, I forget who, but it was kind of in reference to the Netflix problem. And the quote is, more data beats better algorithms. And this is kind of a machine learning type person that said it. But I think that's a really good lesson for hotspot maps, is you want to use more data to reduce the variance and get a better assessment of the heterogeneity in a city. So this is an example. So I'm a crime analyst again. I have my fixed resources in Chicago and say I can only flag 10% of the city of Chicago or send patrols to 10% of the city. If I just randomly sent the patrols somewhere, this is how much crime I would predict correctly, this red line, which is random chance. Now, if I use a 3-week hotspot map, I can actually predict, well, 2 or 3 times more crime than random chance, which is good. And that's why hotspot maps are so widely used and successful. And they're easy to implement. And if I actually go to 3 months or instead of 3 weeks, I can actually get a little more accuracy out of it. And then I've kind of, really a point process is a hotspot map, and a hotspot map is a point process. But I'm using point process to kind of, describe this very mathematically rigorous, you're using maximum likelihood, you're using all the data you have type process. So if you use a point process fit to 3 years of homicide data in this retrospective forecast, then this is the accuracy you get. And if you decide to go back 8 years, you get even a little bit more accuracy. And of course, there's a diminishing return eventually. But I think it's important to recognize you really do want to use all of the data at your disposal. Okay, so the last thing I want to talk about is what we're actually doing in practice. in Los Angeles and Santa Cruz. But first I want to kind of place this also in the context of what people have been doing for a while. And so first I want to talk about hotspot policing and randomized controlled trials in hotspot policing. So the idea here is that because crime is concentrated in very small regions of space, let's focus our policing resources on those hotspots. And the way these trials typically work is you chop up, again, the city into little regions, and you look at crime counts in those regions, and you take the top N hotspots from those crime counts over maybe a several-year period, and then you randomly assign half to treatment and half to control, just like you would in a medical trial. And then you perform an intervention for several months in those treatment hotspots, and then your measure of success is a crime rate reduction in the treatment hotspots versus the control ones. So you're controlling the experiment. So it's kind of worth pointing out that you're not measuring crime rate reduction in the whole region, just in the hotspots. And what these have shown is two things. One, policing is successful at reducing crime in the hotspots. And secondly, there's also been studies that show that crime doesn't typically move around the corner. So you reduce the crime in the hotspots and it doesn't just shift to the next block or two over. So I think the hotspot policing is a very good starting point to work from. But it really just gives you a tool. It says policing is a valuable tool, but it doesn't tell you how best to use that tool to deter crime. So, what I think of as predictive policing, and really, again, hotspot maps are point processes and vice versa. Hotspot policing is predictive policing and vice versa. But my idea of predictive policing is the following. So instead of just focusing on those hotspots, let's treat that region of space holistically. And given that crime is as dynamic, which is what we believe, then predictive policing is two things. It's algorithms that model that dynamic nature of crime, and two, policing methods that dynamically adjust to dynamic crime trends. So that's kind of how I think I would distinguish predictive policing from hotspot policing. But it's unclear, in this context of how you would set up experimental design, because now you don't have a way to control your experiment, which is where you did in hotspot policing. So what do we do? And this is just a starting point. I would be interested to know what people think in this room. But one idea, this was actually by Greg Ridgway at RAND, who's now at NIJ, is instead of randomizing in space, you randomize in time. So in LA, what we're doing is creating 20 prediction boxes each day in this region, foothill division of Los Angeles. And we distribute these maps to the officers before their watch. And each day we flip a coin, and either we give them the point process generated maps, or we give them, the officers, the maps that the crime analyst at LAPD generates. So the idea is you can't really do a randomized controlled trial in space because these hotspots are jumping around every day, but you randomize in time. Okay, so we were looking at three kind of objectives in Los Angeles. One is, can you predict better than the analyst? And I mean, we were pretty sure we would, but this was important for the Los Angeles Police Department to know, because they were a little bit nervous about handing over their patrols to a computer. Understandably so. So that was the first thing we looked at. Is it operationally feasible? Can you really do this, in this almost real time, where each day the officers are getting new hotspots to patrol? So there's a whole cycle where the data has to be entered, the crime analyst has to generate these reports, they have to be distributed, the officers have to make these checks. Is it possible to do this operationally? And then third, do you get a crime rate reduction? So first, the predictive accuracy, and this is we were very happy about. So in interviewing the crime analysts, we had a general idea of how they were creating their maps before, and so we could kind of guess what their basic algorithm was, which was essentially kind of a few-week hotspot map. So we kind of did retrospective forecasts to begin with to kind of estimate what we thought would happen in the experiment, and it turned out the crime analyst predictions fell pretty much exactly on that curve, which was a nice result. And it turns out that the point process does about twice as well as the crime analyst, meaning that twice as many crimes fell in the prediction boxes on the point process days. Of course, this was over 6 months, which was about the limit we could ask this crime analyst to participate in this experiment, because it really did take a lot of work for them to generate the predictions on their day. Oftentimes, crime analysts will only generate these maps maybe once a week or two, and they were having to do these basically every day. So 6 months was about the limit. And it turns out that actually, if you kind of forget about these prior curves, the p-value over 6 months is actually only 0.06 between this, that this is a statistically significant difference. So we would have liked to have a little more time, but I think this is pretty convincing that this worked. So the second thing that we were looking at is, can we actually do this operationally? Will the officers actually make these checks and get to these hotspots each day that are changing? And they did pretty well. So they didn't have, a lot of hotspot policing studies, they have dedicated resources. So the map I showed you before was cadet foot patrols in Philadelphia. So they actually had an additional resource to add to the mix. And we didn't have this. We were just using officer free patrol time. So they were able to make about 3 minutes every 2 hours in each of these boxes, which is not quite what you want. There's a study from a while ago that says you want 15 minutes every 2 hours. But this was what we could get given that the resources that we had at our disposal. And there was some learning curve to get these officers up to speed. The last thing that I'll point out, and this is, again, it's difficult to control these experiments, so this is not a controlled comparison, but if you look at the division where we were running this experiment, which is Foothill out of 21 divisions in Los Angeles, they had the highest crime rate reduction over that 6 months over all the divisions in Los Angeles. And these are selected divisions that have similar demographics and are geographically close. So that was a promising result that we had. Again, though, there's several things that you kind of want to understand and you're not able to do. One thing is the algorithm, but another thing is really the change in the policing process. So they were shifting to micro scale, 150 by 150 meter policing practice. And they were really, ramped up about doing this every day. So there's a number of reasons why you can get a crime rate reduction like this. And I think predictive policing is a whole process. It's not just algorithms why you get a crime rate reduction. So what we want to do in the future, again, we would like to hit this Koper curve mark of 15 minutes every 2 hours. And we should be able to do this in some new divisions in Los Angeles because we're going to have some dedicated cars to do the predictive policing checks. And then, looking back at these results, it makes you want to do some kind of randomized controlled trial to reproduce these in a controlled way. So, one idea might be to do kind of a mesoscale randomized controlled trial where you divide the city into larger grids, not 150 meter by 150 meter, but maybe a couple kilometers by a couple kilometers. And then you do kind of the hotspot randomized controlled trial technique where you divide half of those to treatment and half to control, and then you do predictive policing within those mesoscale regions. And that might be a way to measure if you can holistically reduce the crime rate by focusing on a few micro-scale locations each day. So that's one thing we want to do in the future. So I want to conclude. I don't think I mentioned my collaborators up to this point, but I did not do all this. Jeff Branningham did quite a bit, and when he's not doing archaeological digs, he's programming in JavaScript to do these predictive policing experiments. So he did a lot of this work, and also Martin Short and George Tita and Andrea Bertozzi also are a part of this. And then, as Andrea mentioned, this is a good field for students. And in fact, a number of undergraduates have actually done quite remarkable work on this project as well, in particular Omar Kazi, who's a computer whiz and taken over for Jeff and I. We've had funding from NSF and Army Research Office. And then I'll just point out that everything I should say should be taken with a grain of salt because we started a company called predpol.com. So don't believe me, don't take my word for it. Go and program with the Chicago data yourself to verify point processes work. Okay, so I think that's all I have.
Any questions?
Unless you're going to focus in on just like major crimes like homicides, there's going to be a probability, probably quite high, that crimes are not going to be reported, and that probability is going to have both spatial dependency and temporal dependency. How do you take that into account? Because otherwise you couldn't tell the difference of a hotspot disappearing or just being moved to a neighborhood that isn't in the habit of reporting crime.
That's a good question. All we have to work with is the crime that is reported. So as a mathematician, we're assuming that that the crime data is correct. But you're absolutely right; it's not. So I would suggest this needs to be done in collaboration with the community, and they need to be involved in this process and really encouraged to report crime in order to make this be as effective as it could be. Jeff, did you have a point to say?
Property crimes, I would guess the reporting rate is like 30%, 20%. It'd be really low.
Yeah, so Jeff Branningham here. There are two points here. One is that often the public forgets that crime data is about a partnership between the public and the police, and so oftentimes if people underreport crime, people should be made aware that if they underreport crime, it is a self-fulfilling prophecy that the police will not show up to help you, right? And that further engenders a sense of distrust in the police. So that's one side of the thing. The other thing I might point out is that there are people working on point process models where they, and I've seen talks at UCLA about this, where there are ghosted points, meaning there are points along the lines of what Andrea was talking about, where you can infer their presence in the data even though they might not be reported. But that's an area of development. So along the lines of these crimes, gang crimes, where you don't know which rivalry to assign them to, you can essentially work through the inverse problem of saying which is the most likely location or rivalry in which that's involved in. So great question.
So I have a little technical question for you. I mean, we know that crime rates are not Poisson, that there's a dispersion problem. So I assume from looking at this Hawks process that it can handle over-dispersed, under-dispersed processes.
Well, the Hawks process is not Poisson, so that's.
Yeah, I guess you were starting it with a Poisson process.
Yeah,
and you're branching.
so the way we think about it is part of crime is Poisson, and then part of it is not. So you kind of decompose it into a part that is and a part that's not, and you estimate each of those parts. No, they were having, the only difference was the algorithm generating the hotspots. So it was a single blind study in that each day the officers, and I have this slide here. I didn't point this out, I apologize. The left is the point process day, the right is the crime analyst day. So the officer, and there was a slight difference just how the images worked out, but the officers saw the exact same thing each day. So it was really who was generating these hotspots. Was it the analyst or was it our algorithm? That was what was different. The officers couldn't tell the difference.
There's an announcement. You want, Mike?